Good evening. Thanks for watching. Today I'm working more on my stock market tool as I've been doing every day. I worked the whole day today from 9 a.m. till just now. So what time is it? 11. I worked 14 hours straight on the computer today for my job. And I'm beat down and I'm tired of doing computer work. But here I am streaming again because I have to make progress on this project. The goal is to make progress every day. My goal at the start of the year was to do a stream every day. And so here I am doing a stream, trying to get more stuff done. So, first, before I get started, I'm going to go over where I'm at in this project. But real quick, I'm going to do a quick advertisement. So, all the code for this project is right here in this GitHub. The link is in the description. So go check it out. Please download it. Try using it for yourself and let me know how it goes. Give me some suggestions. Uh, Also, join the Discord. You can talk about it there. You can, connect with me personally there at any time. And I really want feedback on this model. Also, it helps me out if you star the repository, fork it, and or watch it. Also, follow me on GitHub. Um, and subscribe to the channel, of course. So, here's where I'm at on the project. This is way up here now. But let me go over, I guess this is kind of the general idea. So I have data. I want to organize that data into a stock universe, cut out crap data that's going to make the model perform worse. Once I have isolated a good data set, I want to use that data set to train a returns model. I guess I could zoom in on this. It doesn't have to be so small. I want to use that data set to train a returns model. And that model, I was going for directional accuracy, but there are some other metrics I should use. But basically, I need to get a robust model. I need to be confident that I have a robust model. Once I'm confident in that, I want to incorporate that into a portfolio model that I'm going to optimize to make buys and sells. And the end goal will be there's actually two end goals. So the end goal for me is I want to have one bash script that I run each day, sometime after the market closes and before the market opens on the next day. And I just want to say get picks, and I want it to generate picks for me. So I want to get to the point where I don't have to, do any work or analysis. I'll only be doing analysis on my model, but each day in the market, I'm just going to generate my picks. So that's my end goal. My second end goal, which you can see here by the fact that I've put it into a GitHub, is I want to make a tool that anybody can use. So not only should I be able to use this, I want to make it easy for people to make their own models without having to do a bunch of coding. The first iteration of this tool is just going to be in Python, so you will have to know some Python code or get some AI to help you out with creating a model. But creating the model itself is really easy, and there's instructions here. The second iteration, I want to make a web app that will do all of this in your browser so that you can just click around and train a complex model. So, it might have to be, instead of a browser application, it might have to be a, what's it called? Desktop app. And it would be cool to have an app on your phone too, but I don't know if your phone has the compute. So this is what I've done previously. This was really what I did over January. So I got some data. I was using NASDAQ data, and that was actually pretty inefficient because I needed to download a CSV for each stock each day. So I found a better data set. This is also in the description. You can find it there. Also, if you go to the GitHub, I have a link to it, and I also have instructions on how to set it up. So I had to do a little bit of data cleaning, really just accounting for stock splits. I did that. And then I did some basic analysis you can see down here. And this was, my head's in the way. But so this was looking at fundamental variables. And then on the right here, I made a function that can compare any stocks in a sector. So you can see what's underperforming the sector, what's overperforming the sector, winners and losers for a sector. Now that's nice for qualitative analysis, but I want something quantitative that's a lot more reliable. I don't want to have to go through and do my own analysis and draw my own conclusions. I want a model that does it for me. So I incorporated the data into a light gradient boosting method. I did some simple universe stuff to isolate good data. And I was able to get 51.5% directional accuracy. Like I said, this was the initial metric I was working with. Now I have some more advanced metrics to look at, like information coefficient and the ratio of information coefficient to information. Um, and so I did incorporate this into a portfolio model. I found that if I'm picking the bottom end volatility stocks each day, it performs better the lower n is, so the fewer number of stocks I'm picking. You can see at the right here, if I'm picking the 500 lowest volatility stocks for the day and weighting them according to their probability of going up, I'm underperforming the S&P. If I trim it down to 100, I'm basically matching the S&P. If I trim it down to 20, I'm beating the S&P, and if I trim it down to 1, I'm beating the S&P by a lot. So I looked at the Sharpe ratio. You need a Sharpe ratio above 1 to have a successful strategy to implement, at least above 1. Ideally, it would be substantially above 1. And I found that the only one that has a Sharpe ratio above 1 is if I'm only picking one stock per day, which isn't a really good method. So I tried to refine this a little bit by thresholding it. So if I thresholded it at 0.5, just saying probability of going up, it was about 1. If I increased it to 0.51 and 0.52, I didn't really see a big improvement in performance. But when I increased it to 0.53, there was a really big improvement in performance. And at 0.54, I got a great performance with Sharpe ratio of 2.5. And you can see how these performed here on the right. The problem with this is that at the end of the day, it just wasn't a robust method. It's picking one stock per day, and this is really fragile and very risky because if the model breaks one day and I'm running this every day, I stand to lose a lot of money. So, what I decide, and really what this comes back to is this model, the returns model wasn't good enough. And so I could do whatever portfolio strategies I want. At the end of the day, I needed a more robust returns model. And so the problem was with how I had organized the code originally, it was a big mess. And so I needed to write a new script every time I wanted to change how the universe is defined, how the model is trained and defined, and also the portfolio strategies. Each of these required a new script. And so I had dozens of files, and it quickly blew up, or it was going to quickly blow up into hundreds of files, and it would have been hard for me to use, and it would have been useless for anyone else, which kind of negates the second goal I have, which is to make a useful tool for people. So I cleaned it all up, made it into a nice Pythonic library. I added filters for the universe. These are classes. I already had the clean data. I added a class for the stock universe to, like I said, filter out crap. I added feature and target classes. That's what took most of the time. I added all of these features and targets that are highlighted in green here. Magenta I was going to add, but I wasn't able to. And I haven't coded a portfolio model yet, but that's the next step. I'm focusing on the returns model. I do have a class for the returns model, and that's what I've been working on this week. And so this code base restructure was really what I focused on all of February. The initial method was what I focused on for January. So I'm hoping by the end of March I'll be able to get some good models going. This is all incorporating features here. More stuff here. I got the model to work. Let's see. So the first step was to just throw all of the features into the model. The features can look back different amounts of days. Like for instance, if you're getting the moving average, you could get the 20-day moving average, 300-day moving average, whatever, any number of days. You could also lag the features by any amount you want. Although I'm not sure why you would want to lag them more than one day. But you have to lag them at least 1 day so that you don't get data leakage and you know that you're looking at data from previous. You want to be looking at data that's available when the market opens. So that is that basically. Oh, and so the problem with this, if you look, like I said initially, I was looking at directional accuracy. The directional accuracy I got on the first version of the model was 51.5%. My goal was to improve that. Um, and you see here that the accuracy is 50.8, so worse than my initial model. I went through and looked at some different things. Oh, this is classification, so picking up or down on classification. Here I did regression to predict the returns for the day, not just whether it's going to go up or down. This actually performed even worse. And so the next thing was to go through and do a bunch of tests to see what works. Oh, and I looked here at the 4 best features from the model to see, does this improve the performance, and this also made the performance worse. So um, I went through and kind of did an investigation of things. The first thing was to add different time periods. So you want short term, medium term, and long term. So I added 5, 20, 60, and 200-day windows for each feature. And so here it's just doing it on the 4 best features. Here it's doing it on all features. And you see here I'm getting 50.8. So it's still not really much of an improvement. Um, I looked at so I was doing 20 runs for my hyperparameter optimization, and I found the performance wasn't very good, and so I was looking at how can I improve the performance for the hyperparameter optimization, and I found a paper that says you need 500 runs for your hyperparameters. The problem was that was taking a really long time to run, and so I investigated it here. If I only do 20 iterations, was definitely worse than 500. But if I just did 50 iterations, that actually overperformed 500. So I concluded 50 iterations is sufficient. I looked at different loss metrics and I found that root mean squared error performs the best. Initially, I drew this conclusion, which is that I want to use root mean squared error. Um, but I later revised that, and last night I found that I actually don't want to be using it, and this is actually reflective of it fitting, kind of market-wide data, and it's not really performing a regression to the individual stocks, and so that isn't going to work well. Um, what else did I find? Oh, I looked at ranked features. So, tried instead of just feeding the values into the model, ranking the features. So each stock, the number 1 best this, number 2 best that, for each metric. For instance, if you do like MACD, I want to get rank them. So instead of giving the MACD value, it should be number 1 is the value for the best stock, so on and so forth. And then I looked at does changing the target improve the model? And this was a good finding. I found that the further out I look in the future, the better the model performs, which makes sense because it's really hard to get, everybody's working on this, everybody's working on the same problem. It's going to be really hard to get something that is predicting returns for a single day. And then I looked at the variance of the directional accuracy. It was pretty low. But the model initializes with a random seed, and so it's each run of the model is going to be a little bit different. And then I wanted to look at, does the model perform better with or without ETFs? I determined it's better without ETFs, so I excluded ETFs. This is the 5-day forward prediction with all features. So my initial goal, since I was looking at directional accuracy, and I was getting 51.5%. My goal, as I stated it in my earlier streams, was I wanted to get 53 or 54% directional accuracy. And here I'm basically getting 53% directional accuracy. So you think, okay, that should be good. But here I was also incorporating the information coefficient, and you see it's 0.01, which is not high enough. I want higher than that for a useful model. So yeah, that's the conclusions I drew. I incorporated some more metrics to assess the fitness of the model. And so these are all the metrics that I'm currently looking at. I'm printing out directional accuracy, mean daily rank, information coefficient to information ratio, the annualized version of that, and then the information coefficient t statistic. And these are the thresholds that I'm trying to get. So I found that it's performing well on some of them, but performing poorly on other ones. Um, oh, and I also found that I needed to do some uh, neutralization of the target. So basically, take out the S&P 500. I did this using demeaning, so subtract the mean of the returns for the whole market from the returns for the model, and that should normalize it in some way, but there is a better way to normalize it. And so at the end of the day, I still wasn't getting the results that I wanted, anywhere close to where I needed. Um, and so, oh yeah, that's right. So also this. So I thought it was performing well on some metrics, but uh, the mean, uh, the mean IC wasn't good enough. What did I say here? Oh, for the new features, it's close to or above the threshold, but the problem is these features uh, all apply to the daily returns, and so this was kind of a what do you call it? A false thing. I went down. It was a wild goose chase. Um, I forgot why though. Oh, oh, right. So the problem with this is that the days are heavily correlated. So if I'm picking the 5 day forward returns on Monday, those are correlated to the 5 day forward returns on Tuesday. So what I need to do is break the model up into days of the week and isolate, Monday data, Tuesday data, Wednesday data, if I'm doing 5 day daily returns. What else is going on here? Um, Oh yeah, I also the last thing I did last night was I changed my loss metric back to Huber because, like I said, root mean squared error is gonna overweight the outliers, so that's not gonna give a good model either. Um, so these are the things I wrote down last night as my to dos for the day. I'm gonna have to. Um, I don't think I'll get all these done today. Like I said, I spent the whole day working on the computer. It was killing me, so. I'm not gonna. I don't have the brain power to do all of this, but let me look at this and let's pick something. So, the to dos: add transform to feature engine. Okay, so I want that actually will be pretty easy to do with Google Gemini. So let me use that. All right. Desktop work. Stock market tool. Where the hell's stock market tool? Oh, here it is. Scripts, feature engine. So I'm gonna tell it add a transform to feature request class. Which implements logic in the which implements logic in the feature engine class. I want the transform to work like the demean transform, but what? Oh, it should calculate. but it should calculate the cross-sectional z-score. Before, alright, so cross-sectional z-score, I need to understand what the hell that is. Difference between the test score and average. Cross-sectional z-score. Log return. Returns ranks assets at a specific point in time by measuring how many standard deviations their log returns deviate from the cross-sectional mean. Oh, so that's actually really simple. Instead of getting the difference between the mean, get get the number of standard deviations it is from the mean. That's simple. Should it just work on targets, or okay, well, I'll ask it that later. I want to use this for my targets. Also explain whether this will be useful for my features. Finally, write a test which demonstrates that the cross-sectional z-score is working. The test should make a plot which obviously which makes clear that it works. And I think that's it. Okay, so let me put a comment in the chat really quick. Saying subscribe. Okay, let's see here. It is useful for features. So how does the rank work? Actually, I might already have this. Yeah, so that just gives the percent rank, not the number of okay, so I just need to add this CSZ score. Feature request. CSZ score is also valid, okay. Add this. Okay, then let's add to save this. And in tests, test features, let's add a new test for test. That should go here. Test cross sectional z is equal to 1. If test cross sectional z is equal to true, go ahead and run that crap. What's the error? No, don't make synthetic data. Get rid of that crap. What is that? Why does the data loading work so weird? All right, load in the data. Save it. Oh, I'm in the wrong repository. CD stock market tool. Okay, so this I think I saved. I need to make sure this is saved. Okay, let's run it. So Python 3 test features.py. Did I take the other test off? Don't want test beta. Exit, run it. All right. So let's see. Is this gonna work? This morning I bought some oil. I bought, what is it called? US oil. Let me see. It was at 105 something a share. Now it's up to 115 a share. 113 a share. So it's dropping now. But the way I see it, the Strait of Hormuz or Iran's not going to open. There's one of two things that are going to happen in the Iran war that are going to open the Strait of Hormuz. Keep in mind, if the Strait of... God damn, what's that? All right, so now there's an error in test cross-sectional Z. What line was it? Test features, 1275. Of raw column. So raw column is equal to df out dot keys. We're gonna say it's key for key in df out dot keys if t in key dot split it on the underscore. Forward log return close. Forward log return close 1 day target. Print raw call. Okay, so that'll print before the error comes up. Yeah, so the Strait of Hormuz. What is Iran's motivation? They basically they were attacked unprovoked. They didn't start the war. They don't like us meddling in the Middle East. Their motivation is to keep the Strait of Hormuz closed until they get something that they want. I'm assuming they want either the U.S. to leave the Middle East, they want us to remove our bases, or they want the Gulf countries to kick our bases out. So they're going to keep that closed until they get what they want. Now, is the U.S. going to give them what they want? No, because that would be the fall of the U.S. empire. It would be the fall of the petrodollar. And so they're going to have to, basically the only way we're going to do that is if we have no way out. All right, so that should be, all right, target calls equals that. Raw call is equal to target calls of 0. Z-score call is equal to target calls of 1. Run it. Let's see what happens. Yeah, so where was I? Iran's not going to close the Strait of Hormuz until they get what they want, which is the U.S. to leave the Gulf countries. Or if we're not going to leave the Gulf countries, they want, I don't know, like $1 trillion or something, some huge concession. But really, I only see it being the former. And so, or yeah, I guess $1 trillion. If we gave them $1 trillion, I bet they would end the war. But basically, both of those are going to be either we give them $1 trillion, that's going to ruin the U.S. standing in the world. Nobody's going to respect the U.S. All right, here's the plot. And it's not plotting. Oh, okay, good. Explain what I'm looking at in the test. So Iran's not going to go for it unless they get some huge concession. The U.S. it doesn't want to give them a huge concession unless we absolutely have to. Now, from the United States point of view, so maybe you don't wait for Iran to open the Strait of Hormuz. Maybe you can open it yourself. They've tried underwriting the insurance on the tankers. Trump said last week, at the end of the week, they were going to do that. We were going to do that. But then that fell apart today. I'm not sure why. The other option, really you could escort, he suggested using the Navy to escort the tankers through the Strait of Hormuz. But that's not going to work either, because if it's mined, all it takes is one missile flying through. The tankers aren't going to take that risk. They're not going to risk getting blown up. There's no win there for them. So the tankers aren't going to go for that. So the only way you can't bomb, you could, bomb the hell out of the Iranian side of the strait, but that's not going to get you what you want. You could, really the only way is for the U.S. to open it by force is you could send in ground troops or you can nuke it. And neither of those are going to fly. Those are going to be so unpopular, Trump's going to get impeached if that happens. So all that to say, I can't think of any way that the Strait of Hormuz opens in the next week or really in the next month. So I bought oil, crude oil this morning. All right, and I was updating my Bitcoin trade for a while. For a long time, I was giving updates on that, but nobody seemed to find that interesting. I bought a put on the BlackRock Bitcoin ETF, but I sold it last week because when the stock market crashed from Iran, Bitcoin's been heavily correlated to the S&P 500. And so the S&P 500 crashed last week with the Iran thing, and Bitcoin actually rose, which proves the whole thesis of Bitcoin is that it's a store of value that countries can't interfere with, like the US dollar. Um, and so I'm a big believer in Bitcoin, so I'm not going to bet against beautiful Bitcoin. So I sold my puts, but made a nice profit. I made I think it was like a 40 or 50% profit. It was up at 70% at one time, and then Bitcoin made a recovery. I sold it when Bitcoin was around 71,000. I bought it when Bitcoin was at 90,000. So it did really well. Blah, blah, blah. So now I'm into oil, and I'm trying to buy up 100 shares of Pfizer so I could sell covered calls. Let me know what you think about those strategies. And let me know, is there anything I'm missing with the Strait of Hormuz? Is there any way that it opens in the next week or month um, without either the U.S. giving Iran a huge concession, or without ground troops invading, or without dropping a nuclear bomb on the Iranian side of the strait? Is there any other way it opens in the next month? I can't. I can't imagine a scenario. So let's see. What is this supposed to be showing us? When you run the test script, you're looking at side-by-side comparison of raw financial data. So what's the range of dates? Oh, this is the all stocks. I see. Mm, yeah, it's fine. So raw forward returns, cross-sectional z-score. Okay, this is too much. So let's look at stocks to get. Test features. So df day equals that. And then we could say df stocks to get. Could just get big ones. Apple, Tesla, Pfizer, Apple, Tesla, Pfizer, Amazon. What else do we want? Comment a stock if you have a favorite. Otherwise, Apple, Pfizer, Tesla, Amazon. My brain's cooked. I can't think of a stock. Netflix. Let's add a few more. Ford. Stellantis. Okay. Let's run this again. Oh, it's going to show the same damn thing. So stocks to get. Let's put that up at the top. And we could say df is equal to df of df dot account symbol in stocks to get. Okay, so it's still showing this. Way too much crap to look at. My God, come on. Pandas isolate data where column corresponds to values in a list. Oh, is in, okay, good. Dot is in, okay, it's a function. Stocks to get. Good, a lot easier to look at. So Apple had a positive log return, but it wasn't the best. So it's not, what is it? The out of the positive log returns, it was the third best. Oh no, it's how many standard deviations it is from the mean. So this is the mean. So that's more standard deviations from the mean than this. I need to see what the standard deviations are. Below the mean, above. Yeah, I mean, that looks good. So let's put this in the PowerPoint. There's 11 people watching, so I'm going to take this opportunity to say please subscribe and go check out the GitHub, download it, try to use it, give me feedback on what you think about it, and tell me how I can improve it. And also, what's the other thing? Oh, please star it, watch it, fork it, and follow me on GitHub. That really helps me out, helps me get freelance coding jobs, helps me get jobs. Please. Oh yeah, and join the Discord. So, okay, back to business. I've added this. Okay, so let's highlight everything here. Home. Highlight as red or a yellow for to do. And I did this. New slide. Got cross-sectional z-score. So it works on log returns. If I train the same, if I train model explorer. So these are all the different models that I'm trying out. I'm just trying different things. And this is kind of the whole goal. I want some simple functions, classes, and everything should live in files. And then now that they live in files, I don't need to write any of that analysis code. I can just try out different things. And so that's what I'm doing here, is trying out different models. So Okay, if I run the same as model 9, if I train the same model as model 9 using cross-sectional, okay, training model 9, using cross-sectional z score target on log returns. Model 9. So model 9 is same as model 5. Model 5 is same as model 2. So all features. So model 9's that. And then model 5. And then model 9 uses dmean to target. And then model 10, this model, uses same as 9, but uses cross-sectional Z transform on target. Alright, so I could edit all that crap later. Let's put this in test model 10 is equal to 1. So where was the model 9 result? Okay, so we want to do the same thing as this. But transform should be CS Z score. I think that's how it's called. CS Z score. Yep. So back to here. Save. And let's run it. Get rid of that. Oh, no, don't run the test. Get out of here. ls cd explorers ls python 3 model explorer. Why didn't that run? This is test model 10. I've literally spent the whole day just running code, writing code, and doing PowerPoints. And here I am again doing more of it. But at least this is a different project. I was really hitting my head against the wall with work. Alright, so model 10 CS z-score neutralization. Did I explain it up here? No. So let's say 10, same as model 9, but uses cross-sectional z-score to neutralize. Okay, so same as model 5, but uses demeaned target to neutralize. Oh, so 9 is that 1 day returns? Yeah, it is. But that's okay. We want to compare apples to apples. So model 5 is 1 day returns, model 9 is 1 day returns. So let's set up also model 11 model, which is just model 9, but uses 5-day forward returns. Oh no, there's not really a point in that because I need to the metrics aren't going to be good. So what was the terminology used here? Because your daily ICs are no longer independent events, I'm looking at mean information coefficient, IC standard deviation, ICIR, and ICT statistic to assess my model. However, if I use 5-day forward log returns, these metrics, the latter 3 metrics, will not work properly because there is heavy correlation between different days. Therefore, I need to split the model into Mondays, the training data, into Mondays, Tuesdays, Wednesdays, etc. Okay. Is the model done yet? No. Oh no. Alright, let me save this in a text file so I can type it later. Yeah, so now I incorporated the information, the cross sectional z-score into the target for my model. I pasted the model file, the file which contains the model class. I get the following error when I run my model. Why is this the case? Yeah, the following error during the hyperparameter optimization when, take out this when, they're all failing, yeah. So let me paste the script. I don't think this is gonna output anything. I think I'm gonna get an error. Oh, how stupid. Okay, so this should work. Okay, so let's go back to trying to incorporate the other thing. Here's my prompt. However, if I use 5-day forward log returns, therefore I need to split the model into training data. I don't want to I don't want this to work only for 5-day forward returns. I guess, yeah, 5-day forward. So, let's think, because I want to do not just 5-day forward returns. If I do 30-day forward returns, it should do that too. The problem is Mondays are kind of a certain thing in the market. Tuesdays are a certain thing. Wednesdays, you know, so on and so forth. So I have day of week. I'll just say I'm having trouble thinking of what logic to use. On one hand, I want this functionality to be diverse so that it works for any amount of days I want to look forward. For instance, this should not only work for 5-day returns, splitting into days of the week, it should also work for 20-day forward returns. I have determined that the farther out I look, the better directional accuracy I get. Yeah. So, yeah. But it is also the case that Mondays are different from Fridays. So 5-day forward log returns should be a special case. It might also be that monthly forward log returns are also no. Same with if no, I'll just what should my logic be for what should my strategy be? Okay, how did it do? $50.5%. So it is better. Well, it performs the same as no neutralization, basically. However, it's much better than demean neutralization, and it's harder to train a model that's neutralized than one that's not neutralized. So this is an improvement. Oh, yeah, look at the information coefficient. because the mean daily information coefficient, actually all these are valid because it's predicting returns 1 day out. So T statistic is way better. All of these are way better, right? 0.17. Yeah, T statistic's better. ICIR is better. Daily ICIR is better. Standard deviation of the information coefficient is larger, so that's worse. Mean daily rank, is way better. So finally, the information coefficient is better than the standard deviation, is at least the same order of magnitude and is actually a greater value than the standard deviation of the information coefficient. So I think this is an improvement if I add in the feature performance. So here's the performance of the features. Let's add that in. Does transforming all features with cross-sectional Z improve, which I'm doing this in model 11, improve the results of model 10? Okay, let's see. So now let's add in test model 11 is now equal to 1. Let's add in here model 11. I could type that while it's running because the z-score transformation, it seems like, takes quite a bit of time. So test model 11 is equal to true. Is it midnight? Wow, it's past midnight. All right, so model 11, test model 11. So now I want to add this transform to every single one, except for the calendar stuff. Okay, so that's already at the bottom. MACD, let's transform that. And let's run it. So now let's explain what model 11 is here. Same as model 9, but all features have been transformed with the cross-sectional z-score. Save. I don't want to add anything else. I don't want to have to add anything else when I am creating the model. The split should be its own function in the model class, and it should I don't want to have to add anything else when I'm creating the model. The split should be its own function, and it should automatically be called when the target time period is greater than 1. Help me think about this. Oh, did I run the new model? Yeah, it's going. It's just taking a really long time. This might be because I have too much stuff open. I have like 10 PowerPoints open. Let's see what it says. You've stumbled upon a classic fundamental problem when you predict end-day forward returns every single day. Your target variables overlapping. For example, yes, I know. Everything's heavily autocorrelated. Gives me a false sense of confidence. Do not split the training, split the evaluation. Oh. So it's fine for training. It's just that when I test it and get the metrics, that's when the issue comes in. Okay, cool. To make this work dynamically for any amount of days, we can assign every date in the test set to a path ID. That sounds complicated. Sort all unique dates in the test set, assign each date a path using modulo arithmetic. This perfectly separates path ID. Path to where? A file? How to implement this with minimal code. You can extract n. That is more complicated. Break it into a separate function, separate method, which goes into the model class that handles the splitting. Then what the hell? So it cut out a bunch of features. But this is concerning. It's just learning it says the most important feature is gap sigma. So that's 200-day gap sigma. So it's basically saying things that have gone up over the last 200 days are going to go up. Things that have gone down over the last 200 days are going to go down. And that is because it's learning on a bull market. But okay. I could just put a note in that says that. Break it into a separate method which goes into the model class, which handles the splitting, etc. Then I should call this method. Target parts. Try. Find the next part that ends in D and is a number before D. Except default to 1. Assign non-overlapping paths. Then I should call this method. Inside oh yeah, so I need to get what are the results of this test. If I do z-score on each one of these, it performs worse again. Very confusing. So we took a step back. But why would that not improve the model? Why would cross-sectional z-scores? Oh, 0.0011. So that's the same. 0. Oh no, the daily rank I see went up. Oh. So daily rank I see is better. Standard deviation is higher. ICIR is much higher. It's put some notes here. So directional accuracy is slightly better. Information coefficient is much better. Information coefficient sigma is worse. Daily ICIR, I could just say 0.8, 0.2, 0.01. Yeah, so ICIR is much better. .5 to 4x improvement. T statistic is much better. So this is actually, I'm not sure what to conclude. It seems like it's slightly better than one, and actually it's better on every metric other than the information coefficient standard deviation. This is model 10 is normal targets. Model 11 is transformed targets. Oh, transformed features. This is normal features. Do I want to say anything else? LGBM dropped many features. That's kind of interesting. It found the other features are not important. Another interesting thing is gap sigma over 200 days is most important. I believe this means that it's really just learning whether the stock is going up or down long term. I think this is an artifact of the bull market. Most of the time since 2011, we have been in a bull market. I'm actually going to put that in its own text box. All right, so kind of all the conclusions to draw there. I think this appears to definitely be an improvement. So dynamically find n from the target key, assign path IDs, group. Okay, so that's a function. Get daily IC. Well, I could just test this on one of the other ones, and then I can move forward from there. So now just replace the regression block. So what's new? So if target is regression, so mean IC, yeah, so it should go under this. So everything below here I can remove down to the print. Mean rank IC. So that's the old method for getting metrics. And below that, everything should be the same. So 5-day forwarder targets. Model 8. Performance on demeaned target. Good. I did save it here. So make sure this is saved. Now let's go to model 8. Turn on model 8. Turn off this guy. And let's run it. Get rid of the plot. Okay, so let's say here previously model 8 gave the output below. So what was inflated? IC standard deviation, ICIR. Okay, so now let's see how it performs. My computer's making noise. Whoa, it's hot. I think I'm beating the hell out of it right now. But that's what the computer's made for, right? May as well use it. Okay, we're only on trial 17, so yeah, let's see if this improves things. And then let's add another test. So test model 12 is equal to 1. Now 12 should be same as model 11. This is same as model, not 9, model 10. 12 is same as model 11, but uses 5-day future target. should add the I should add that transform, but I'm not going to because I want to compare apples to apples. So now the target should be the same as the target for model 8. So model 8 target is this, but I want to apply the transform. But if I transform the target, I guess I can weight the portfolio according to the z-scores. How many standard deviations? More standard deviations is more weight, but yeah. Anyway. So it should all contain that, yes. And so let's see if model 8 gave us more accurate output. 1.75. Whoa, it's higher. Oh, hey, Vacant. Yeah, just a sec. Let me put this into the PowerPoint really quick. Then I'll explain what I'm up to. This isn't making any sense. Alright, so T-score is better. ICIR is better. IC standard deviation is lower, so better. Mean daily rank IC is higher. Directional accuracy 52.9. Directional accuracy is worse. This performs better with new metrics. This should not be the case. Why is this? So yeah, there's no point in running that new model. I need to figure out the metrics. The new metric function shows even better results than the previous logic showed. I am expecting it to show worse results. Why is this happening? What is wrong? Okay, Vacant, here's what I'm up to. So, the goal is summarized here. So, I have some data I have stock market data. It's daily data each day for each stock that's included in the New York Stock Exchange, each stock that's available on the New York Stock Exchange since 2011. So 2011 going to current day. I'm using is my camera foggy? I'm using a database which updates every day. So I have whole bunch of stock data. From that, I have every stock over every day since 2011. So from all of that, there's going to be a lot of crap in there that's going to ruin the model if I try to train it on that, like penny stocks, That's kind of the only thing I could think of. Oh, stocks that don't have a lot of volume, so that aren't trading a lot. If you look at the market, sometimes you can find like weird stocks that kind of go flat and then jump up, and it's because volumes, or then jump down, and it's because the volume's really low. So I don't want it to train on anything like that. That will just ruin the performance of the model. So I want to isolate a universe of stocks. The next thing is to train a machine learning model on all of the stocks to predict something, either returns or probability of going up, or whether it's going to go up or down, or something like that. Predict something with the stock, and then use that model, feed it into a portfolio allocator, and then that should spit out, here are the stocks to buy for the day, and here's the quantity to buy them in. And the goal is to get something that beats the S&P 500 by a significant margin. Um, that's the first goal. The second goal is to also make a tool that's useful for other people. So I want to do this, but I also want to make a tool so that anyone can do this with ease. And so what I've been doing there is I'm adding all of this to a GitHub repository, and now I have it cleaned up in a pretty good state. And this is a Python tool, so if you know Python, you can use it, or you can use some AI to help you use it. And eventually, I would like to incorporate this either into a web app or a desktop app. And that should, have a GUI just like any other app, so you don't have to code at all. You just have to click around, make the model how you want, and you can do the same thing I'm doing. That is the idea. So kind of two goals. One, get something that makes money for me. Two, make a general tool so anyone can develop their own strategies. So the first iteration of this, I started out with data from NASDAQ. That turned out to not be good. I got a better data source. That's linked here. I show you how to get it. It's also linked in the description. I did a basic analysis of fundamental variables, also compared stocks in a sector. But this is qualitative. You're not going to be able to automate this. I want something I can automate, so I incorporated a light gradient boosting method, which is a machine learning method, basically. It works really well in stock data. It handles missing values well, and it handles large data sets well, both of which apply to the data that I have. I found some portfolio strategies that worked here. Basically, the problem was that this portfolio strategy was really fragile because it was only picking one stock per day. And if I picked more stocks per day, it wasn't a successful, more than one stock per day, it wasn't a successful strategy. And so the next thing I really had to do, what it comes down to, is the model, the returns model. The portfolio strategy wasn't my issue. The issue was the returns model. And a model that's only returning 51.5% accuracy just isn't good enough. And so I've been working on this project since the beginning of this year, really like December 29th of last year. But basically, this has been my project of this year. And so the next thing I needed to do was go through and rapidly iterate. There are all sorts of features you can implement. So I need to rapidly iterate on the model, try all sorts of different features and targets and transformations and strategies. The problem was I had written the code as a big giant mess, and so I needed to write new scripts every time I wanted to do something different. This made the code base really big. It blew up into dozens of files, and by the time I'm at my current point, it would be hundreds of files, and it would become unusable for me, or at least very hard to use and completely unusable for anyone else. So that would ruin my second goal of making a tool that anyone can use. So to keep in line with that goal and really to make it faster for my prototyping, I incorporated everything into this here, which is a really clean Python package that will do all of this for you. So I don't need to write hundreds of scripts. I just need to, explore the scripts that I've already written. And so the initial version of this model I did in January. This was really my project of January. Doing all of this was my project of February, and it took so long because I incorporated all of these features and targets. So it's a lot, and I had to make sure that everything works properly. Once I had that, I went through and started exploring the model. So I started just, send in every single feature that I have into the model and see how it works. You see initially I was looking at directional accuracy. Now I'm looking at more advanced metrics like information coefficient to information ratio, the standard deviation of the information coefficient, and the t-score. But for directional accuracy, before I was getting 51.5%. If I feed in every feature that I have, it's getting 50.8%. So really it got worse. And so I needed to go through and see, how can I improve this? So I tried all sorts of different things. I found a few that worked. The main thing I found that really worked was that if I'm using forward target, like instead of trying to predict the returns for today, predict the returns 5 days from now, 10 days from now, 30 days from now, I found that it performed a lot better the further out I'm looking. So 5 days, predicting the return in 5 days is easier than predicting the return for today. 10 days is easier than predicting the return for 5 days, so on and so forth. So that was a really good finding. This is from the other day. I was just doing all sorts of things. Yeah, so basically I found some things that worked. I found out yesterday. Yeah, I tested each feature individually, and that's actually, so that's what all this stuff is. So here I'm going through demonstrating the features work. So here's a whole bunch of features here. Yeah, so I had to make sure everything worked properly. Is Buddy outside? Oh, you're at the door, Buddy. We'll go out soon. Yeah. So I tested each feature individually. What else? So today, what I'm basically working on is trying to improve it more. So I found that cross-sectional z-score improves it a lot. And now I'm trying to. So the problem is if I'm doing 5-day forward returns, it works a lot better. But these metrics at the bottom here are going to be falsely inflated. And so I'm trying to fix that so that they're not falsely inflated. When I tried to fix it, they were even more inflated. And so that's kind of the problem that I'm working on right now. And there's been an error with the Google Gemini, which I'm using. So really, it's way after midnight. We're getting close to 1 a.m., so I'm going to call it for now. That's it for this stream. The first thing I'm looking at tomorrow is how can I fix these metrics and make them work. Please subscribe. It helps me out if you subscribe. It also helps me out if you go to the GitHub, download the repository, try to use it for yourself. Tell me how I can improve it. Leave a star on the repository. That really helps me. It helps raise my coding profile, helps me get freelance gigs, and helps me get jobs. It helps if you watch the repository. And it also helps me if you follow me on GitHub. So subscribe, go to the GitHub, do all that stuff. And finally, join the Discord, which is in the description of the live stream. But that's it for now. I gotta walk my dog before I go to bed, and then I gotta get to bed because I gotta be up in 5 hours for work. So, thanks for watching. That's it for tonight. Have a good rest of your night. Tune in next time. I'll be working on this every day. So, yeah, tune in if you want. Adios. Oh, you're out there. Poor guy. Come on. I gotta end the live stream.